so in this segment, I'm going to be showing you, explaining in details the embryonic stem cell, which is found in the embryo, like I told you, the stem cells in animals where it's found, and the capacity, then the meristematic cells from plants. So let's work things out. So number one here is I'm going to be taking it like this, like that. So the embryonic stem cells are found inside on the inside layer of an embryo, like if you have an embryo like that, like not very nice like that. So this inside layer of the embryo has embryonic stem cells there. Yes, and that stem cell can differentiate. What's the potential? These are undifferentiated or unspecialized. They've not taken any function. What capacity do they have? They can form any type of specialized cells, can be formed from them, like seriously. That means if you take the stem cell from this embryo and you put it in the brain, it's going to form the type of cell around it. That's why it is used medically, even though it's still debatable at the moment, can we use it or not, but we are going to see that when we get to that part anyways. But the point is, it can form any type. It can form bone cells, it can form muscle cells, it can form fat cells, anything. I mean, any type. That's the capacity of the embryonic stem cells, and this is very, very valuable. Yeah, very, very valuable. I mean, it's of great importance in medicine now, but we'll still talk about that later. Then the adult stem cells, well, it is found in different places. Well, I just work with these. Like I used to believe like it's more in the bone marrow. Now let's work things. I'm going to explain why my reservations on these. Now it says here bone marrow have limited ability to differentiate. They are actually partially differentiated, yes, or specialized. This is the reason why. In the bone marrow, like the bone marrow of somebody, I'm drawing a very funny bone there. So they have this thing there called bone marrow. The bone marrow has something called pluripotent stem cells. That means it can form any type of cell, but it can form only blood cells. Blood cells. Now, what are the blood cells? It can form red blood cell, white blood cells majorly, then platelets. So these are so it can't form anything other than blood cells. It says these are mainly, I'm here now, these are mainly found in the blood and hence forms blood cells. I mean, just blood cells. They can't form any other thing other than blood cells. You can't say they can form muscles, they can't form muscle cells, they can't form nerve cells. So that's what we say. They are partially, they have a great limited capacity. I mean, because they can only form, so they can't be used to say, okay, someone has a brain problem, they want to take stem cells from the bone marrow to use it. It won't work because it's limited. Then we also have stem cells on the skin. Well, these stem cells, to me, they are not even stem cells. They are just there to replace what was there before. Have limited ability to differentiate. They are actually partially differentiated. Yes, they are found different layers of the skin and hair follicles. What are they doing? Replacing what was there before, basically. Now, these ones, we have blood from umbilical cord. Yes, when you give birth to a newborn baby, you have some stem cells there. Yes, which is the remaining from the embryo. Then these ones also have some specialization. I mean, they can also form, they have limited potential, but they can form blood cells, muscle cells, and nerve cells. Yes, or nerve tissues. So they can form a bit of a wider range of cells, but it's not like those that can form any type. The stem cell from embryo cannot form any type, but can form a wider range than the bone marrow and skin cells. So that's what you should know there. Then he says here, other organs such as liver and brain, okay, have limited ability to differentiate. They are actually partially specialized to found in these organs. So they are found in these organs. So this is meant to be in this organ. They are found in the organ, like the liver, found in the brain, and basically they are basically working for that particular organ. Basically, that's why I said I have some reservation, really. So all of them are just partially differentiated, have limited ability to differentiate to wider range of cells. Basically, they can form so much of specialized cells. Then we have meristematic cell from plants. It is found on growing regions of plants such as shoot and root, even the stem. Now they are fully undifferentiated. Yes, they can form anything. It says one single cell has the ability to divide to produce a whole new plant. Beautiful. So that means from one single cell, it can form the roots, can form stem, can form the leaf, can form cortex, can form the xylem, phloem, and all of those things. So the point is, the meristematic cells or meristems from plants, which are the stem cells in plants, have a very wide range of ability to differentiate, just like the embryonic stem cells. Really hope this has been helpful. So that will be all for now. I'm going to see you. Okay, this is explaining it some more. Good. This is the brain cells. You can see that. Because this is multipotent, well, just for the brain cells. So this is like the adult kind of thing. The heart cells, that's what we call the multipotent stem cells. Like, well, they are committed to form that thing they have already, like what they already have. That's what they can really form. They can see the bone marrow that can form blood cells, basically. But for the meristems in plants, like I told you, are found in different parts at the tip. For growth, lateral meristem, that one allows this plant to get wider because they are undifferentiated on the side, so it causes the cells, the plant cell to get wider, basically. All right, that will be all for now. Hope that explanation has been helpful. I'm going to see you in the next. Bye bye.